Yes, so I think it's almost 10 o'clock. Good morning to everybody who's already there. I think a couple of people will join a little bit later, but that's fine. Yeah, we will have a nice hour together now. We will answer your questions. We will talk about ALMA, our Advanced Leakage Monitoring and Alarming for smart maintenance. We will tell you exactly what we mean with that. I'm very happy today. I'm joined here with two colleagues, Simon and Heino. Both of them have many years with STEAG already. Simon, almost 10 years in total, from the projects first, now waste to energy, cement. You are one of my colleagues in the team there, so thank you for joining today. Maybe you can say a quick word what your role will be here today, please.
Yes, good morning, everybody. Well, hello, everybody from me. Yes, I will be one of the moderators for today's event. So if you have any technical problems, any questions, you can ask me directly via the chat. So if you have a look on the right side of the window, you can find the chat tool. If you have any questions regarding our event or regarding the technical stuff, please put them into the box, into the chat box. Only we, so Dennis, Heino, and I can see your questions. We will answer them private in the chat box, or we will ask your questions again to Heino, and yes, we try to answer everything in this event.
Exactly, thank you. On the one hand, yeah, everybody who's already here that seems not to have problems. So those that cannot connect should also reach out with an email. So that's why I'm checking here sometimes if somebody is reporting. But now let's come to Heino. Heino, you have decades of experience. So let's not make you older than you are. 2 decades of experience here in that field. You are the product owner and manager of ALMA and also of the suit blowing. Maybe a couple of words to get a deeper understanding where your experience comes from, just quickly.
Yes, I am with STEAG for almost 20 years, like you mentioned now, and I'm an engineer for energy and process technology, and started at STEAG with some project work with performance monitoring, and then later on I proceeded to optimize suit blowing tools, and the last project I covered is the Advanced Leakage Monitoring with ALMA.
Yeah, thanks. So to finish here, I'm Dennis Braun. Most of you know me already. I'm one of the sales engineers here in the team. We help to find out with the customer if a solution is really suitable for them. With colleagues like Heino, we will have in detailed talks beforehand, so really make sure that the solution fits to the task that you have and the preconditions that you might have there. So, oh, is the music playing? I hope it's not. There's no music here right now. You can maybe stop it on your machine. Somebody is mentioning music is playing. Just check if you can stop that on your side, please. Okay. Yes, I don't have the music here anymore. So good. Let's see. We have 2 parts. So a quick overview for those that have been here in the last webinars. You can get a cup of coffee now. It's just for those that are here for the first time. We really refer to our experience. And so everybody should know what STEAG is doing, where the experience is coming from. And then in about 10 minutes, Heino will take over and we will have a deeper look into the concept of ALMA, what it can do for you, how it works, and we will even see a live demonstration here. And at the end, we have about 10-15 minutes remaining to really go into your questions. Depends on how much questions we have. We might be needed to switch a little bit in the time schedule here. And I have a couple of polls. Let's start with one here to see if everybody's awake and with us. We asked you in the registration process from which industry you are, so we don't have to ask that again here. But there we learned that most of you are from the thermal background, which is not a surprise since we talk about ALMA, which is for boilers. So good job, you made a nice choice here. I can see many answers coming in. If you have a power plant, what kind of fuel do you use? And we see here lignite, hard coal, gas, and other, but mainly gas I can see here today. So that is good. Heino, maybe you could keep that in mind and help the audience to understand where that reflects. On the other hand, I think that was I will share with everybody. So thanks for voting here. On the other hand, I think it's a difficult question. Most of our customers have more than one unit, so that might be like the main fuel only. So, but it's interesting to see that. Let's see. Right. Let's ask one more question before we get going. Exit this one. And good morning to you too. Yes. So please, one more question here. Do you already have microphones? That will be helpful for us here to really make sure that we have the right level. So those that have microphones could maybe click for one unit, for all the units, for some units. Oh, you know, somehow it didn't work. I don't have microphones at all, so sorry for that. Okay, great. Okay, thank you. Let's share the result. Interesting. So that is really, an audience today that is really right in the focus. So let us go. Let us show you quickly what STEAG does, and then Heino can show us exactly what ALMA can do for you. I will quickly share my screen with you. Let's go. And let's have a quick look here. I think it's connecting. Here. Looks good on my screen, but it doesn't look good on the client. Oh, that's coming here. Good. So on the client screen, I can see it's working. If you have problems here on one screen, I don't see it. Just hit the refresh button and it should be there in a minute. Okay. So how the advanced leakage monitoring and alarming helps for smart maintenance and dispatch decisions. You already see in the title, it's about what the software can do for you, for your real work issues there. It's not about, like just software. It's about helping you in your daily business. So since the background, our experience is so relevant for everything that we show you here in our webinar series, very quickly, for those that don't know STEAG, we are a company that's active in the whole world. In Europe, our digital solutions here is more than 50 gigawatts currently monitored with our solutions. And ALMA is one of those solutions here. I will show you the stack in a second there. In the Middle East, we have installations in India for sure. Also, a nice and warm hello to those colleagues from India that joined us today. And of course, Southeast Asia and China. It's a very growing market there, and already we have currently 10 gigawatts there. So also hello to everybody there and everybody else here from Europe and so on who I didn't address directly. STEAG in total has more than 6,000 employees. We have more than 100 gigawatts that are optimized with our digital solutions, but we also do the operation and maintenance for more than 11 gigawatts around the globe with local colleagues and everywhere. But that is really for us so important that it's not just an idea, not just a software, it's really experience. That is really what matters in the real world for our projects and for your projects. Just a couple of numbers here, pretty quick. For example, here, the boiler cleaning management, which Heino is also responsible for, as we discussed a minute before, more than 66 gigawatts of power plant capacity are using that. Other modules that we have, it's in total more than 20 countries around the world. So you see, it's not something new, not something we just invented yesterday. It's really well proven around the globe. What are our digital solutions? Well, they combine the owner's perspective. They combine O&M. That's why I had to show you before that we actually do that. So we know what best practices are. Plus, when we talk to our partners, our customers in the projects, of course, they let us know what their best practices are that they want to have implemented in those projects. Plus, since we have so many projects, as I just showed you, we can afford to have that like a cutting-edge digital systems there. Since it's on so many shoulders, it's really making sense to really have an efficient solution there. It's about maximizing availability. Another goal is to improve the plant load factor and efficiency. It's always about reducing maintenance costs and about avoiding unplanned outages. That's very important, since when I know there's an outage soon planned, if I have knowledge, I can react and I can make sure to use that outage to fix something. And if I don't have the knowledge, if I don't have the software, the project, the digital solution that helps me, I cannot do it. And then I have a bad surprise afterwards. So what are those things that I show you here? It's all part of STEAG's asset intelligence framework. So at the bottom, there's a couple of software products. We combine that with our and the customer's experience, different applications, different fields here, from the lifetime monitoring to operation maintenance and so on, data science. It's all part of that asset intelligence framework. But then comes the most important part, maybe, to really have the knowledge as well, how to put that into the daily work of our customers and partners there, to really allow to have insights to be turned into actions. It's not about a screen that is just showing something. It's about the people on site being able to do the right thing for the highest benefit of the owner and operator and so on. And to show you that those digital solutions actually have a lot of impact, we have different examples here taken from several projects here. I won't go into all the details here. Most important, in the middle, we have the payback period that's below 1.5 years typically. It's, for example, here, a coal-fired power plant. Since they were able, with the digital solution, to decrease the unit heat rate by performance monitoring, they were able to save ongoing, every day, 8,300 euros, and so on. Other examples here with the predictive maintenance, they save 1 million euros because you can use a planned outage and avoid an unplanned one. So that is all possible here. Good. Here's an invitation for you. First of all, of course, our next webinars, our Energy Week in November, but also if you today think, well, ALMA sounds good, but I'm still not sure if it fits to our unit, our technology that we apply, you are invited to contact Heino or Simon or me, and we can later see with your data, with your question, if that fits, and many times it fits, but I think that it's really worth, and we can have a private meeting afterwards here online and really find out if it makes sense for you and helps you to have those benefits that many other customers already can use. Before we finish this introduction, I would like to share only 2 slides with you to quickly show what is ALMA. Already the abbreviation we had, it's Advanced Leakage Monitoring and Alerting. It's an IT solution for detecting those leakages in the steam generator. It's a system that is early and reliably notification giving to the operators that something is wrong. It's an add-on to acoustic sensor systems, and it connects via an interface to those other systems, as we will see with Heino soon. And it's able to detect leakages first. And of course, there are different possibilities to detect leakages. Heino will go into those details soon. But for us, it's important, early and reliable, to give the information that something is wrong. We see here from the pipe water coming out for those that haven't seen that or not a feeling what I mean. So one example here to show you what this knowledge can do for you, and then my part is over and Heino can take over. We talk about this. Yes, please.
Dennis,
please.
Can I interrupt you
please,
only
please.
for a short second? Here are coming some questions about some problems with that the people can't hear us.
Oh.
So maybe you can give me or us a short feedback in the chat if you can hear us at the moment or if you have problems. So please give me.
I also recommend to do the refresh, F5 on your browser. I can see here on one client it's all fine. On the other one, I still have the slides not coming, so I will also refresh here. You can also copy just the URL from the top of your screen and reopen your browser and just jump right in again. That should also help. But that's good that you let us know if something's wrong. I think it's very nice. It's only browser-based here, but on the other hand, of course, like a full software is also sometimes a little bit more stable. But yes, since we have power plant customers, in many cases, local installations are typically not possible for our audience. So we went for something that is completely without any software installation. Good. Let me also refresh here. Let me get my mouse. Good. Start playback. Good. Yeah, after refreshing here my second computer, I see the PowerPoint, I see the cameras. So hopefully that is helpful for everybody. If not, as I said, copy the URL, reopen your browser, and it should be fine. Do not use the link from the invitation because that is one time only. This confirmation, this webinar link should work perfectly. Okay, so if you don't mind, I will just finish my example here and then we can switch to questions and Heino. Here it was about the knowledge that we can use for making better decisions here. And we see a normalized KPI of noise emissions here. On the bottom, we have the timeline, and we see the level, the average level that goes up here. At the bottom, that's how it should be, and that is what's actually going on, because there must be some leakage somewhere. So what you already know is when you have planned standstills, when you have outages. And here everything is fine, so you don't do anything. The leakage starts pretty small, and it's very difficult to detect it. But in this case, our ALMA, since it's so precise, it gives a warning with an email, so you are aware. So you focus, you check how bad it is. And since the leakage is not so bad, repairs can be postponed. You didn't make it here for the first standstill, it was too short notice, but you can go, I think that maybe like a week of time here. You can go a couple of days keeping an eye on the issue, but it's not a problem yet. So you schedule maintenance, and here it breaks, and here those consequential damages were avoided since you have the knowledge and you can fix it before with a planned standstill. What that means in detail, we will see with Heino, but that is just the big message here. You can use that knowledge to avoid unplanned outages, and that's very valuable. And you saw those numbers, what that could mean easily, lots of money. So that is very helpful. Good. So that was my quick overview. Now we will switch to the cameras for a moment, just to see if everything is okay for you. Let me see. Stop sharing. Good. So Simon, Heino, was there anything to add? Oh, I hear somebody cannot hear me. Whoa, it's really problematic today. Okay, maybe Heino will take over. I will push F5 here, and hopefully everything is better then. So let's continue with the next part. So Heino, the stage is yours.
Okay, then thank you very much for your good introduction. And I hope my sound is good, and I will start sharing my screen. So if everything is set up right, then I'll start with my presentation. It's about ALMA, as Dennis already introduced, and I will talk a little bit about boiler leakage in general to provide some background, and then I will explain how ALMA works and early detection is implemented. And at the end, I will give a few examples, and we can have a look at a real ALMA system, what it looks like, and how to use it. Why do we talk about boiler leakage? Well, leakage plays a relatively large role in unplanned shutdowns, mainly in coal-fired power plants. In the survey, we saw that about 50% of the participants is working on gas-fired power plants. There, that leakage topic is not such a big issue, but in the future, it might play a larger role if frequent startups, shutdowns get more into the daily routine. Then the stress on the tubes will be higher, and possibly more leakages will occur. Leakages and unplanned shutdowns are pretty expensive. Just an example of an 800 megawatt power plant. Just 5 hours of downtime mean financial loss of some about $50,000 up to $100,000. And I'm sure that is the lower part of the range of the cost. And because of this high cost of financial loss of downtime, early and reliable leak detection would have a great financial leverage. If we get a way to detect leaks very early after it's coming up, and then we would get a lot of time to react, to plan the maintenance, repair, and save a lot of money. We should have a look at the causes of boiler tube leakages, because if we want to detect something, we should know how it occurs, how it works. Erosion is a big topic with tube leakages. It mainly comes from soot blowing and from the ashes in the coal that erode the tubes in the boiler in the flue gas path. Thermal stress also plays a role. So during startup and shutdown, there are big temperature gradients, and those cause stress on the tubes, and mainly weldings get stressed and tend to break during shutdown or startup. Chemical corrosion also occurs when there's a lack of O2 in close to the burners. Then CO corrosion can affect the furnace walls and cause damage. And last, and perhaps the most important cause for leakages are leakages. That's not a mistake. It is the fact that many leakages cause secondary or subsequent leakages. You can imagine steam or water under high pressure getting out of a small leak or hole can cut neighboring tubes. And this is what we call secondary leakages. And this is a big issue. And these secondary leakages, of course, are growing and getting more the more time it takes from start of the leak until shutdown for repairing it. This picture shows a typical secondary leak. So you see the erosion and the wear of a tube where the steam of the upper tube, which is not visible here, simply cuts through the neighboring tube.
I know maybe that's a good moment to ask one more question here to the audience, since we prepared exactly that. We have, how many leakages do you have per year? Those that know, maybe you can quickly give us a feeling. Yeah, very often, very rare, not at all. Yeah, don't click. We can see more than 10. Oh yeah. So it's nobody said one already. Everybody is having more. Okay, I will share the results. Thank you all. Thank you. See, that is, oh, there's more coming. Wow, no one. Good, good. But so maybe another question to finish that here and not interrupt again soon. Let us see. Yes. What's that? Yes, those subsequential damages that Heino just mentioned. Do you know that, or is that not an issue for you? Currently, it's a little bit mixed here, but most people that voted said yes. If something is wrong, of course, we have additional problems afterwards. So I think that's enough. Thank you all. Let us share the result. So Heino, what you just said, everybody is confirming. If something's wrong, it just gets worse. So that's it. I'm going back here, and I'm not sure if you have to share again, but
Probably, yes.
I'm done.
So thank you for the confirmation of all the participants. It's very interesting to learn how frequent secondary leakages are, and also the other information, how many microphones are installed, and so that's very interesting for me. So thank you for that. So we stopped at the causes of boiler tube leakages, and of course it's a question how to reduce loss caused by the leakages. There are two approaches. The first one is, of course, avoid leakages at all, and the second approach is, if there is a leak, then we should try to reduce the cost of that leakage. Avoiding of leakages is possible by optimized soot blowing in a way that less soot blowing, and soot blowing only where it is really necessary, because there is some fouling or slagging on a heating surface, will reduce the erosion caused by the steam and by the ashes moving upstream through the boiler. Second approach, addressing the CO corrosion, can be combustion optimization by leading the combustion air in a better way, so to avoid this CO corrosion.
Heino, I think it's worth mentioning that we can provide that as well, right? This is not part of the ALMA package, but it's part of what we do. So if somebody has a problem there, they can also reach out and we can have a project or a discussion about that with them as well.
Yes, right. So both topics are pretty interesting, but today we don't have time to address everything regarding leakage. So we will focus on early detection and reliable alerts to reduce the cost of an existing leak. And one task, of course, is to avoid subsequent damages. And in the case of slowly growing leaks, we even can convert an unplanned shutdown into a planned one. And as you mentioned, Dennis, in your introduction, if you can avoid an unplanned shutdown of 1, 2, or 3 days, then you can save a huge amount of money, and each system would be paid back with this one avoided shutdown. So early detection, reliable alerts is our topic today. And to go into details, let us see how leaks are detected today. There are some measurements in a plant with respect to the water flow, steam flow, that typically are used to detect leakages. The most important is, of course, mass flow balance of water and steam. So if we compare the feed water entering the boiler and the amount of steam leaving the boiler, if there's a increasing difference, then that's an indication of a leakage. Same would be with the deaerator level. If there's a leak in the water steam cycle, then the water level will go down and the wake-up water flow will increase, and to refill that, to replace that missing amount of water. These approaches do not apply to all leaks. For example, in the superheat steam area, this mass flow balance of feed water and live steam does not apply, and these criteria are pretty inaccurate. If once you see a difference in the mass flow balance of water and steam, then the leak is already pretty big and it is very urgent to act. So there's no early warning if you watch these water steam data. Similar data are available in the flue gas path. Of course, if water or steam enters the flue gas in the boiler, the flue gas temperature is affected. Furnace pressure can change, but also these indicators are pretty inaccurate and come very late if a leak has big progress. Best we have today are acoustic sensors that are microphones that are listening to the noise in the boiler. You can imagine if there's steam passing a tiny hole or high pressure water passing a tiny hole, then that makes a lot of noise. And the microphones that are used as acoustic sensors are listening into the boiler and detecting any kind of noise. And last but not least, of course, the experienced technician who walks along the boiler listening for sounds is the most reliable source, unless you have ALMA. So let's continue.
But ALMA is on duty 24/7, and I hope that most people don't have to work that much.
Yeah, very good. So the goal is to early detect and to reliably detect. So we want to save time. That's why we now have a look at the process and the time axis, what is going on if there's a leak. When a leakage starts or begins, some time passes until it is noticed, or until the first suspicion about a leak arises. During this time, the leak can grow and can already start cutting neighboring tubes. So once there is a suspicion about a leak, there's a cross-check typically necessary. So other data are taken into account and discussions in the control room start whether that indication of a leak that has been noticed is pointing on a real leak or some false alarm, and maybe finally some operator is sent to the boiler and to go by himself and listen. And all this should lead to the decision whether to shut down the boiler or not. This is the most important, and because it is a very costly decision, it has to be taken carefully. And ALMA addresses both phases from the beginning of the leakage until the first suspicion. This is the early alarming part, and the second phase, cross-checking the suspicion, is the part that ALMA covers with respect to reliable alarming. The more reliable my first suspicion is, the shorter the time can be until I can shut down the boiler. So there are acoustic sensor systems installed, many of them, as we learned in the survey here. So let me give a few explanations how these systems work for those who don't have it installed. There are microphones, sound sensors installed outside the boiler because they are sensitive to high temperatures, and they are listening, as I explained, to the noise in the boiler, either by the air. There's a tiny tube leading into the boiler, so the microphone can directly get the sound of inside the boiler, or there are sensors getting the sound that's emitted by the structure of the boiler, especially in the section of water walls where we don't want to penetrate the wall. These structure-borne sensors are installed. Typically, up to 30 sound sensors are installed in a boiler. Then there's some cabling to connect everything with an evaluation computer. And this evaluation computer brings together all the signals and performs some kind of evaluation, filtering, and so on. And on the right, we see an example of such an output. And what we see is some red areas, some yellow hints, some green, and some blue. And all is connected to a constant alarming level. And to me, this picture does not give clear indications whether there is a leak. The red indications, is it a typical leak or is it a false alarm? Where could it be? Because it is all across the microphones. So it is very difficult to decide based on such evaluation if there is a leak.
Heino, may I ask a question for this
please.
time? So you've talked about the microphones, and you said we have microphones. And the question from the audience is, do they have to use the STEAG microphones, or can they use their own microphones if they have installed some at their plant?
Yeah, that's an important point. So any microphone from any supplier can be used. We just collect the analog signal of each microphone, so representing the loudness or the volume of the noise it detects, and that's all we need. So we are completely independent from any supplier. So we stopped with this not very clear indication on the right screen of an acoustic leakage detection system. And why it is so difficult to get a clear indication, we can see on the right in the trend chart of a microphone signal, of a single microphone signal. In the center of the chart, we see some gap. We can assume there was a leakage. That's easy to detect right now in the retrospective. But if you compare the signal structure before and after this break in the center, there's no big difference. And probably it is very difficult to detect a leak based on these scattered and fluctuating data. But there's a way, of course. ALMA can process these data to give clear indications based on this scattered signal. And this processing of data we call advanced analytics. And now I'll explain how that works.
And just Heino, for organizing purposes, we have 25 minutes remaining. So I think we're good currently, but just to let you know. But yeah.
Okay, thanks. Yeah, so advanced analytics in context with ALMA, with leakage alerting, how does it work? So there are two phases in this process. First is learning, and the second phase is the application in an online system. The learning process is used to feed neural networks with the real data of each individual microphone. We do this based on selected periods. That's called supervised learning. So only data where we are sure that the microphone was in good condition, it was clean, it was working well, are trained. And this training covers all typical operation modes. So full load, part load, different mill combinations, and different fuel if it is available. So that we are sure all information and all data when a microphone is in normal operation are inside this neural network. Once this is done, it is like a brain or universal formula for each microphone. We will apply it in the online system, in the ALMA system, and the first step during the online evaluations is to compare the current actual values of each individual microphone with its respective expected values. So the light blue lines in the right screen are the actual data, and the dark blue is coming from the neural network. For that current operation mode, we expect some different noise. It's a first indication, but you see there's still much scattering and fluctuations, and the quality is not much better than before. Next step will be normalizing the data by calculating the ratio of the actual value and the expected value. And the result is an indicator, performance indicator it is called in data science, which is around 1. If the value is exactly 1, then the actual behavior matches the expected value perfectly. If it is different from 1, then there's some deviation. What we get by this normalized data is an independence from load, from mill combination, and so on. So it is a first step to generalize the data. But it still has a lot of peaks and fluctuations. And if we would apply a constant alarm limit to this characteristic, we will still get a lot of false alarms. That's why we implement the next step, and this is where the most know-how is in, and where we spend a lot of time to improve the system, is to apply statistical filtering and different trend evaluations and other routines. And doing this, we get a very stable and clear signal or plot, and with reliable indications. The red dots represent an alarm given by ALMA. And if you compare the lower trend with the trend up here with a lot of scattering and so on, you see it is much more easy to derive the alarm.
So Heino, when I remember this picture like 2 slides ago where 7 or 8 red bars were there, ALMA would say there's 1 bar, 1 problem, 2 problems, or even 0 problems right now, right?
Correct.
This is the level of pre-processing here, right?
That's correct, yeah. Okay.
Simon is currently having some issues here, but it's no problem. I can see a question here as well. A question was how the location can be determined. Yeah, how what is the result of ALMA analysis there? Could you elaborate a little bit?
Yes, let me answer briefly, and later when we have a look at the system, at the live system or demo system, then I would like to come back to this. Please remember me if I forget. So there are several ideas to further process these data, like get an information about the location or get an information about the type of leak by frequency analysis and Fourier transformation and so on. And all I heard about that was that the suppliers of such systems who tried to improve this finally stopped working on this topic. And
but I know it seems like this is maybe rocket science in some this Fourier and so on. I see the question here. That's a good question. Thanks for asking. Can ALMA distinguish between the noise of the soot blowing and the leakage even? I think that is, without ALMA, an issue in the world.
Yeah, of course, the microphones cannot distinguish, but we know about that soot blowing issue, and we use the soot blowing signals as an input, of course, for the neural networks, so that the neural network knows that there is soot blowing going on, and then can consider this in the further evaluation, of course. But the microphones themselves do not distinguish between different types of noise. Let me give one example from...
Well, I know, I just read here that some people are having issues today. I'm not sure what's wrong. I think there were a couple of updates to the system that we are using here 2 weeks ago. Those that are still here hopefully have no problems. If anything is, refresh or even restart your browser. And those that get kicked out for any reason, we will make sure to distribute the recording soon. And if you have more questions that you cannot ask today, just send us an email and we will include that in the after work here. So some people say everything's fine, others say they cannot reconnect, which is strange. I will make sure to talk to the company afterwards just to find out what's wrong today.
Yeah.
Good.
Oh, that's a pity. But for sure, I will be available, or we will be available for later questions and feedback.
Some people say everything's fine and others cannot reconnect. That is crazy, but we are good. Okay, like about 15 minutes remaining, so let's make sure to look at the live demo as well. But maybe if I wouldn't interrupt, it would be faster, right?
No problem. But okay, let me continue. This is an example. I would go into detail of a violent leak. So violent leaks are happening quickly and producing relatively big leaks. So that's why it is called violent in the other type of leak is slowly growing leaks. So starting very, very small, and there's a lot of time going on until it is a big leakage. So here we see a violent leak, and we see the red line, the power generation of that unit we have a look at, and we see the shutdown in the center. And the characteristics is very difficult to analyze. Let me have a closer look. Only thing we can see here is this area. Hope you can see the mouse cursor, where the signal is a little bit different. And we can see here started that leak on the left corner of that bar. That's the same event, same data, just processed by ALMA, and you already saw this, and we see the clear indication. And if we compare the point in time of ALMA's first alert and the leakage, then we can see that it was at the very beginning of that period where we have that loud noise. So that's the earliest point in time where a violent leak can be detected. On the right, we have some comment of the operator about this leakage. And what I would like to mention is took about 38 hours to repair this leak. That's a good job, considering that you have to cool down the boiler and to find the leak and to cut the tubes and weld new tubes. But it is 38 hours, and if you remember the financial loss of a few hours, then this 38 hours represents 300, 400, 500,000 US dollars of financial loss. And I think you can agree, if we can shorten these downtimes by avoiding secondary leaks in subsequent leaks, only 1 or 2 times a year, only a few hours, then we would be able to save a lot of money. The operators, of course, do not have to monitor these ugly trends of the sound signals or of the ALMA signals, ALMA status signals all the time. They get an email notification each time if one microphone changes its state to an alert state. This email can be sent to a different groups of recipients, of technicians, performance engineers, operators, as the process in the plant is, and it contains the most important information to make up the first decisions. There are 4 diagrams included. I will show it when we are on the demo system, and it is the basis for the first decisions. In the user interface, you can have a closer look, and maybe here I come back to the question about location of a leak. The circles represent the installed microphones, and if it is red, then there's an indication caused by ALMA that there's something going wrong. And that's the only accuracy about locating a leak. So we can say on the right side, in the lower part of the heating surfaces, there the leak must be. So it's not very accurate. Of course, depends on the number of microphones that have been installed. The more microphones, the closer you can identify the location. But it is not that exact or accurate as it might be expected. Just to point out, it's on 68.5 meters, the second tube on the left side of the boiler. That's unfortunately not possible. And I love this picture again, a leak with a subsequent leak in the lower tube. So that's why it is still here. And that's a good opportunity to switch to the real system, to the demo system we prepared. Here it is. Hope you can see it all. We see the visualization of our system. And we've used this same visualization for our performance monitoring, for our optimized soot blowing. And it is a view on our data historian that keeps measurement data. We show it in white fields and calculation results that are in gray fields of our modules installed. And you can go into detail with other screens. You can open diagrams, so it is perfect for later analysis of events and of things that happen. Just let me put some data in it. I want to see 1 month of data, and I can examine data, for example, trends of characteristic curves and so on, very easily, very quickly. Okay, but this is not ALMA, so let's remove it. For ALMA, there's a separate view. This is an overview of all the sensors installed. In this case, we have 14 microphones in the boiler. We see the location where it is, and we see the heating surfaces to have an orientation. And we already mentioned soot blowing. If a soot blowing is going on, then that specific heating surface is marked in blue color. And the example I want to show you happened in December, so I switch to data from December. Speed up a little bit right now before Dennis gets too nervous. And
it's very kind of you, Heino.
no problem, no problem. So we see red the generator output, and in black one microphone's raw signal. And I want to show you this shutdown, this maintenance shutdown, repair shutdown, at the beginning of December last year. So let's go more into detail. 1 week, we see here it is shut down, and right before the boiler was shut down, we see a lot of red dots, which means different alarms by ALMA. We see this bar representing the volume of the microphone sensor at very high values in different areas of the boiler. So this is a clear indication of a big leak right now. If we have a look at the noise level, we see a slow increase at this microphone number 12. We see the alarm started maybe 1 day. So we have 1 week here on the time axis, 1 day before it got really urgent and the boiler was shut down. But this is only one microphone. Let's go back in time, 6 days back. Still one sensor is giving an alert. And what I want to do is add the signal of this microphone. And what we see up to the 27th of November, we had a regular pattern, to speak, and starting on 27th, slowly increase in the lower limit of the volume. And on the 27th, late night, the first alarm was given by this sensor. And if you check, here we have the shutdown. It was 6 days before the shutdown happened. So the operator had a lot of time to prepare and to evaluate, because he noticed, okay, it's a slow increasing leakage. I have some time. I try to plan my shutdown. He tried to plan, but he waited too long in this case, because he wanted to reach the following weekend, but that did not work. But at least he had enough time to schedule all the work, to prepare the material, and to shorten that outage a lot.
And Heino, you said it's difficult to make this decision whether to shut down or not. I think if you provide even to your management this kind of a graph and say, well, that was last time, this is this time, that's why I propose it, I think everybody should have much more confidence in this kind of request to shut down or try to go on, right?
Correct, that's a good point. Confidence is very important, and confidence grows with each leak that ALMA detects.
Right.
So when it's the first detection of ALMA, you are very, very carefully and with your decision, but over time you will build up trust into the system and learn how to interpret all the data.
Do we typically support the customers when they are not sure or still in the learning phase? How would we support them to have your knowledge, for example, available for their own decisions?
Of course. So our knowledge we collected over the past years in this leakage detection is part of the engineering, of course, when we set up the system, and when we help to calibrate and to repair and to work on the microphone sensors. And once this is done and the system is online, we are ready on a regular basis to review the system and to give hints. And of course, if the customer has a question, then we are available all the time for this.
You could, like we are right now, sharing the screen together, have a look together, and really exchange the knowledge that the customer has about the plant, that you have about the system. Okay, because I think this kind of confidence, that's the most relevant part, maybe, of the whole effort here.
Yeah, correct. I would like to share another view similar to the view that is covered in the emails. So we have this clear indication when something turns red, then we have an alert. This is the 27th. Of course, customer gets this information when the first alert happens, not like here when 7 days have passed. So some additional expert diagrams and the chart showing the actual value, and in dark blue the reference value. And even some journal is there. If once a microphone has been calibrated, that might be important information in a retrospective. And
you don't have to log into the system every day. You can just wait for those emails as well with the whole report.
Correct.
Oh yeah, that's
all,
nice.
all I've shown here will be available in that email.
Yeah.
And you also can get an overview. This is also available in any web browser in your company's network if the IT routes this web page to your workstation. And you can see the overview of all microphones in one chart and see how the alerts develop. And you see this microphone sensor 9 was first, and later on the others came up additionally, and finally here was the shutdown period to repair.
I think that was a great example how to use that advanced detection to have the smart maintenance, to really decide what to do. Since we are coming to the end, maybe you could give from your experience like the most relevant feedback you would like to share with your summary maybe, and then if there are more questions that you would like to send us, we can have them after 11 o'clock or even afterwards in smaller groups.
Okay, so I'll skip this nice example. There's some quotes of the users, but the summary, of course. Our advanced analytics, which is included in the ALMA system, helps us to get information about leakages much earlier, especially if it is a slowly increasing leak, and much more reliable, so that we are able to make decisions on a better base and on an earlier point in time. And converting information like this into like this is what we do with ALMA, and that's what we like. And last page of the summaries, so accelerating the process of decision making regarding shutdown can help to minimize subsequent damages, and that will help us to minimize the financial loss caused by these downtimes.
Great.
And finally, I would like to finish with another quote by a customer who states that he included this system in his daily routine and that it got pretty important to him. And that's kind of feedback that makes me a little bit proud of my work. Okay. Yeah.
Good. So we have a little bit time left. So maybe one quick question we can have here. One question is about the calibration that is required to be carried out on the microphone. What is the maximum temperature that microphone sensor can withstand? And maybe let's go back to the camera view maybe, so we can finish with our here. Good. So I know, what about the temperature fields that the microphones can see, and what about the calibration that's needed?
Yeah, temperatures. I'm not pretty sure it is not too high. That's why the microphones are mounted outside the boiler and outside the insulation of the boiler. So there are tiny tubes leading into the boiler inside, and these tubes lead the noise to the microphones that are located outside. So temperature is an issue, but it is addressed by the way of mounting it and so on.
Maybe more details can be provided by your local partners that you have for those kind of works on your boiler. They should know specifically what temperatures are permissible and what is not. Good.
And calibration, of course, we need to adjust the dynamic range of each microphone individually to get the most information out of it. Typically, if the microphones are not maintained very frequently, some are always on the higher level of volume, showing the higher volume, and others do not show even the peaks because they are throttled down or less sensitive, and we have to adjust and calibrate all this together with the customer.
Good. So there's one more question, but let's be on time. It's 11. Thank you all that have to go somewhere else now. Let us know your question, or as I said, challenge us with your data. Let's have a talk afterwards to really see what's possible for you. So thank you also for the interaction here. My apologies that the software was a little bit unstable today. We will figure out until the next time what it is. Hope to see you again soon. And let's have one more question as a bonus for those that have a little bit time remaining. Question is, have you ever experienced with fault detection signal? For example, you decided to shut down by the ALMA signal detected, but there was no water tube leakage in the plant. So like a false alarm, Heino. Did that ever happen?
I haven't heard about that
Yeah.
so far, and I'm sure I would have if that had happened. So, of course, the operators tend to be more on the safe side before shutting down the boiler, but nevertheless, the information provided by ALMA will shorten this process really.
From one
really
customer
much.
I once heard, he was happy he was using the ALMA alarm since it was so reliable to trigger some person to go there. As you showed, if somebody's going there every 8 hours, it could be almost 8 hours, and if you just missed the moment. So I think nobody will just make the decision based on the email, but maybe the email is the trigger then to go there, check it out, and really
Correct.
find out what's up. Great. So I don't know, is there something to add? Heino, please feel free. Otherwise, everybody, you can have another question here right now. We have a little bit of time remaining here in our bonus round. And
bonus round is
yeah.
sounds good. But I would have a lot of things to add, but let me stop today and here and continue in
yeah, that was today was an overview, right? That was we had to keep it to a certain detail level, but we are happy to go into more detail, of course, if somebody is even deeper in their own decision making already, or they know exactly what kind of microphones they have. We can have a talk. I think that's pretty efficient. Those those technical discussions that we have. Good. So there's more coming. Can it be used in steam cracker in a refinery?
Oh, we should have a try. I don't know. I'm not sure. So the let's say the most extreme example I heard was use it in a fluidized bed boiler, because there's a lot of additional noise caused by this ash bed flying around. But even this works. So if there are frequent leakages in a steam cracker, why not? I haven't heard about it, but should be worth a try. Yeah.
Great. And I think the last question that I see here is also it's perfect to finish today. The customer already has microphones and a system to analyze it. So maybe that's what we saw with those 7, 8 red bars. Heino, can they use the ALMA with the existing sensors?
Yes, of course. That's the idea, the basic idea of ALMA. So we would connect to that system and import the output of it into the ALMA system, combined with some other readings from the plant, and then ALMA will do the evaluations.
Let's say the sensors are perfectly fine already. Every fine-tuning, everything is good. If we would start today, how long would it take to implement the ALMA? This is for what you showed us today. Yeah.
So I would say after kickoff, we would need 2 weeks. Assume the computer is ready and everything around, and the interface is ready. We would need 2 weeks to get it online. And following these 2 weeks, there would be a period of 2 or 3 months of fine-tuning from time to time to learn the typical behavior of each individual microphone in that specific boiler. But the first results, the first indications would be available after 2 or 3 weeks.
Good. So another question coming in. Also for me, next time I have to make the letters a little bigger or get closer. Does ALMA also provide the possible root cause of the tube leak?
No. That's the thing that would be very interesting, of course, but the sound does not help analyzing it. As I already mentioned, some suppliers of these systems try to apply Fourier analysis and so on to find out the shape of the leak, so to have an indication of the type, but they did not get results that are good enough to be applied to an online system, and so it still stays at the maintenance personnel to have a look at the leak and then to identify the cause.
Right. Let's see today that I hope you all agree this was not a sales pitch. Yeah, you have to buy ALMA. It's a solution for all problems in the world. but customers typically, they have different modules anyways. Yeah, maybe additional measurements for the soot blowing. Customers ask, can we use our infrared cameras as well? So this is not just a box thing. If you have, that's why I said challenge us with your specific situation. Let's see what can be applied. Maybe we have this root cause module as well in our portfolio. Maybe combined with what you already have is the best solution there. So I'm not sure if I fully get that. Somebody's asking for the interval for ALMA maintenance. Maybe that is how much effort does the ALMA make ongoing after the project phase to keep up to date? Maybe that's the question. Yeah,
that's a very good question, because the neural networks that are the basis of ALMA, of course, require some retraining or new training. For example, if you exchange a microphone, or if you do some major maintenance work on a microphone. But this is done very quickly. Within a few hours, the neural network has been retrained, and it occurs every few months, so it is not very often.
And maybe that's a good point to say, who's able to do that? Do they have to call you and pay the German fees, or can somebody else do it?
They should call me, but of course, it is pretty easy to understand how to do it, and customers have access to the full system in each configuration modes, and we can teach them how to do it, and then it could be done by themselves.
If customers have more than one unit, typically they take somebody who's getting this training, to get everything done. For everybody else, or if you don't want to do that, we have those local partners around the globe, what I showed in the beginning. So even our project partners there, either the customers team or our partners there that we collaborate with, they can also provide locally that kind of, like quick support, quick training. And if something is very difficult, we can always have a meeting together with those experts here, even the programmers of the specific module that we are using. I mean, that is really this partner approach there. If you find something together, we will get to the bottom of the issue. Great. Okay, one more question. Thank you. I'm really happy that we have this interaction here. So please keep asking if you have anything else on your mind. Will the ALMA provide the analysis of the soot blower effectiveness?
That's a good question. I like it, but it is less related to ALMA. For the soot blower effectiveness, we have a separate module. We call it BCM, Boiler Cleaning Management module, and this one can exactly determine the cleanliness of each heating surface and allows to compare the cleanliness before and after each soot blowing, and you can derive trends and effectiveness of soot blowing and a lot of stuff around it. So it's a very comprehensive tool, and that would be another 2 hours of web seminar.
Yeah, our current series is without BCM, but we are already thinking about next steps. So maybe we should have Heino again for an in-detail BCM approach here. Also here, I think that was very, very interesting today, Heino, when we see what the questions are. Somebody's already having the process monitoring system currently implemented from us, and they are asking if it's possible to add ALMA. So, do we need a separate computer, or does it take forever, or what is possible there?
Does it take forever is good. No, of course, as it is an add-on, it will be added on the existing system. We will use the existing historian, the interfaces, everything can be reused, and it would be a little add-on on the same machine, would not affect the performance, because ALMA does not require high performance computers. That would be an easy job.
Maybe we should talk about that afterwards. So sometimes it's even more efficient if you already have a project ongoing. We can use those meetings, those trips if necessary. Those, it could be very efficient to just combine that right away, right? And here's another question coming. If you can upgrade, if you just start, you have the microphones, you get ALMA. Can you upgrade also to something else afterwards? Can you upgrade ALMA with the soot blowing that you just mentioned? Or can you upgrade to this predictive maintenance solution that we looked at a couple of weeks ago? I know, is it upgradable?
Yes, for sure. Maybe not upgrade, but extendable. So you can add any module from our portfolio, one after the other, independent of the order. You can start with ALMA, you can start with BCM, and that's completely independent from each other.
Yeah, I think with Joshua a few weeks ago, we also looked at the big data approach, the machine learning. I think that is maybe the most special thing that needs really typically a stronger computer, but everything else, if a standard industrial server that people get for the performance monitoring or for suit blowing, that is capable to have 1 or 2 or 3 additional modules there without any issue. So yes, thank you. Somebody's writing for the Q&A. It was our pleasure. Thanks for the questions. There's one more. What is the key parameter required for microphone calibration?
It's the dynamic range, the level of volume. So we need to find the balance between lower values if the boiler is shut down, for example, or in part load operation, and the highest possible value to get all these operating points visible in that signal. So the volume is the key parameter. Yeah.
Now, in the discussions before, you said that the volume is, you have to see it in comparison with the already noises going on anyways, right? The suit blowers and everything. So it's more complicated than just looking at level, I would like to say.
In the evaluation, you are right. But during calibration, it does not matter. We need to cover the complete range. To make sure that the range is inside this analog signal coming from the microphone.
Okay, that's good to know. Good. So is anything else on your minds? Please, if you have a question. Oh yeah. Do you have any application that can monitor the tube thickness?
No, sorry. No, that would be very helpful and interesting. No, all operators I know are measuring the wall thickness during their maintenance, shutdowns, overhauls, and noting it in some kind of database or tables or whatever, and following over time the thickness, how it changes, and to derive the possible date when to change a tube.
Yeah, but if somebody's worried about that, maybe actually managing the wear and tear makes sense. The suit blowing module that we didn't show today, to really make sure not to use the cold water or the steam on some already damaged surface or like thin surfaces, right?
Yeah, you could consider this knowledge about the wall thickness in the suit blowing strategy. That's true, but the other way around does not work. So from the BCM, you will find out the wall thickness, or from the ALMA, that's not work. Yeah, not any other module we have does support this.
As a rule of thumb, if something is possible, it's part of our portfolio, and if we don't have it, there's typically a good reason why we don't have it. Even though we would love to have some features there, but yeah, we cannot change physics as well. Right? Good. So last chance, last questions here. Otherwise, we have to finish for today. But it was great fun. Thanks for all the questions here. And for those that had issues, again, my apologies. We will find out what was going on today, and hopefully next time it is even more smooth. And we will have the recording for those that participated pretty soon, a couple of days, and you will it's a little bit of post-processing necessary, but it shouldn't be too long, and you can see whatever was not going good. And well, as we said, Heino, maybe even in person from already done projects, take the possibility, get in touch with us, with Simon, with me, with Heino, send us a message, and we can arrange whatever is necessary. Or if you're in contact with any of my sales engineering colleagues here, of course, we can also manage to find the answers for you. But great. So yeah, let's say enough for today. It was a pleasure, as I said, and hope to see you soon again. And really, if something's on your mind afterwards, make sure to get in touch, and we will solve that together. So yeah, let's finish for today. Thank you a lot, Heino, and thank you all. Goodbye.
Bye-bye.